Hi guys, I'm going to record a short video on how to use Aspen and how to navigate everything for this project. So first off, you go to the homepage. Under modules, we have this project assignment that Joe made. You can see here is the objective. The objective is to become more familiar for designing separation processes, and you're going to be doing more Aspen and design in CHBE426 Design 1 with Dr. Shriram this fall. And so it's really important. It's like a precursor to that. You're going to learn about multi-component distillation, or you're going to use that. And so we'll use the Fensky, Underwood, Gillen FUG method with Kirkbride's okay. So you guys are given a mixture of hydrocarbons. I think it's 5 of them. And then you have a total condenser and partial reboiler for the column. You are given the initial pressure, and you have a feed stream composition, a percent recovery, N-butane, and Armin. And you're going to use FUG method, just like Ara explained last week. As you can see here, once you do the FUG hand calculations, you're going to design it on Aspen, rigorous design. I'll explain that a little bit. You have 5 parameters that you can change. You have reflux ratio, operating pressure, feed conditions, feed location, number of stages, and essentially the idea is you have 5 people in your group. Each one of you guys should be doing one of the parameters, and we'll talk about how to do a sensitivity analysis to make this more effective. Yeah, so you want to write a report and explain how all of these properties like impact your separation, and your heat duties, your temperature of your condenser and reboiler, they'll have different temperatures, and your product flow rates and composition. So this is kind of like the selectivity. You're going to prepare a written report as well, and it details what you need to do here. Also, you need to know how to do K values. I'll explain that how to do on Aspen as well. Yeah, so it shouldn't be more than 3 pages of text. You can see your groups right here. You can see your feed. So if, for instance, if I was in group 1, like Chris, like team 1, then you look at the feed conditions. You need a recovery of 98% of N-butane and distillate. So that's in the like in the top, and then multiple of Rmin. So this is what R equals Rmin is. So this is R equals 2 Rmin. Here's the rubric. So it's pretty similar to what we had when we took the class, R and I. To give you an example of how to do the Aspen, I will explain using the first discussion problem, D1. I'm going to try to pretend we have a mixture of this feed of propane, isobutane, N-butane, isopentane, and N-pentane. And I will show you how you do example with that in the distillation column. Additionally, I sent an announcement, so please read this. This is how you navigate UDrive and VPN. Without UDrive and VPN, sensitivity analysis is going to take hours. You do not want to take hours. So please follow the directions here. If you don't have Aspen, you need to get Aspen. Once you get Aspen, please follow this sheet. This is from Dr. Shriram. And this explains how to get the UDrive. And you need to get the UDrive. It makes your life much easier, especially since you're on Zoom and you're only meeting through Zoom. And then here's other helpful Aspen videos. And this is a video that Noah, one of our UTFs last year, made. So if I miss anything, you can just watch this video as well. So I'm going to open this tips and checklist. What you need to do is, I have Windows, so I can't really explain how to do this on Mac, but you're going to follow these procedures in the pink. So basically follow all the procedures, but instead of G Shriram, put your EMD username. Mine would be like Elcho418. You can see right here, for those of you who have Windows. So you can see File, Explorer, Quick Disk PC. I know this can be confusing, but what you need to do is you scroll down. I see right here, Disk PC. Click Disk PC, go to the Computer tab. This is the Computer tab. Click Map Network Drive. So you click this guy, right? Map Network Drive. And it's going to say, which letter do I want? So I want the U drive. Okay, so once you have that, you are going to see folder. You're going to replace this guy. You're going to copy and paste that. I'm going to copy and paste this, but instead of that, I'm going to have Elcho418, which is my user. Actually, you just put that in, and then you click Finish. Yeah, so that's what you should do. I don't know why it's like being weird right now, but essentially you will click that and then you click Finish. Wait, actually, first off, you need to get VPN. So follow the directions to get this VPN. log in for access, you need to download a VPN. It's through Cisco. Once you have the VPN, I'm gonna Google Cisco because I already have it. So I click it. It's not gonna let you connect unless you do this first. I forgot about that. So put in your password, connect. I'm connected to VPN now. Great. Now I can click finish, and I think it should let me. I don't know why it's doing this. Okay, I'm not gonna deal with this, but I already have it. Essentially, you should connect to it. It's either Z or U. Right here, I have this drive, as you can see. It's not connected right now. I'm not sure why it is like this, but eventually it will show up on here. Okay, so I couldn't figure out what's going on, but basically you're trying to connect. You have a connection to a computer, and you're looking for your U drive, which is, if I open this Aspen right here, it's on the PC of the virtual computer I'm connected to. Is right here. You want this address. So basically this address is what you're trying to put into right here. I keep saying I can't find the computer, but it should work. I would just, somebody like email IT about that. You click finish and then you would be connected. Essentially it should show up right here. You can see my VCL user space shows up here. And it's the same thing as this guy. I just can't connect to it for some reason. If you can't do this, just contact the EIT. Right here, you can click help and support, and I think you can ask them. You can just email them and ask them about this. I highly recommend you get a U drive, or else it's going to be very slow. Get the VPN and get the U drive. Okay, so going back to the project. So I'm going to mainly focus on how to set up Aspen. So we'll go back to this Aspen and see right here. You can open files, open. So I can open files on my U drive. I personally like having a USB drive. So for instance, you can see here, there are a lot of Aspen files. That was for my final project in design. Okay, so now you can see here the main flow sheet. For instance, here you can see there's a lot going on. You can see like there's billions of valves, reactors, PFRs, columns. So this project is only gonna focus on a column. You can have a lot of pressure changers and flash tanks and everything, which is what you'll do later. But I'm gonna start off with a new blank simulation. That's what you want to click. Don't click this one. Click blank simulation. We're doing a open system, not closed one. So click that. I don't know why Aspen is being a little slow. Okay, so I'm gonna go back to, for instance, this discussion one. I'm gonna put in the feed parameters. So the first thing you want to do is put in the components. So let's say I have propane. So I can just type propane. Alternatively, you can just search. I would put it on equals, don't do contains, or else you're going to get a huge number of results. So the next thing we had was isobutane. So you want to type isobutane, see if we get isobutane. Okay, so you can double click it or you can just click add selected compounds. So we have isobutane, N-butane. Let's add N-butane. We're going to add isopentane. It says ipentane. Add. You don't want to replace it. We're going to add N-pentane. So there's N-pentane, add selected compound, add. Okay, so now we got all 5 of our compounds. We're happy about that. So we can click, honestly, when in doubt, you just click next. So we added the component specifications under components, under properties. We always start with properties because we want to define our thermodynamic model here. So we're going to use common as a method filter. The base method is going to be whichever one you choose. In this case, we're going to use, I guess, Suave, Redwick, Huang, but you can decide on Peng Robinson, Suave, Redwick, Huang, Unifac, Wilson, any of the, I wouldn't use ideal. You can click help at any point, and there's something really neat called the method filter and the property method assistant. You can put, this is a hydrocarbon system. Does the mixture contain petroleum assays or pseudo components? No. We have these three options: Peng Robinson, SRK Suave Raowiquan, or LK Plock. I don't know what that is, so I wouldn't use that. So you probably want to use Peng Robinson or SRK. That's what I've seen before. So I would use SRK for this example. So you can see here, now it says SRK here. You're going to keep these all the same. All we're going to do is now click next. The only thing we wanted to change is base method here. So we specified our thermodynamic property and method, which is going to use. And this is pretty neat. So this is how you get all your thermodynamic properties. You can see right here, you want to get some K values. So let's see. So this is component I, this is component J. These are binary parameters. So this K value relates these two. You're going to get binary interactions right here. There's a way to get the K values. I think you click mixture, component, and put the flow here. The properties to report. Okay, so this is how we do it. So you want to put your mixtures in, isobutane and butane, the isopentane and N-pentane. We have pound mole per hour. So we have 2.2 pound moles per hour, 171.1, 171.1. Okay, I'm gonna just type it 226.6, 28.1, 17.5. So we got all our components. We're happy about that. So I forgot to, okay, so once you do PS, you want to find K values. So you are going to look for KVL right here. So you want KVL, you click OK, yes, because the K values are what we want. I'm going to just remove PS1 because it has nothing on it. You can change your temperatures here. So the K value is changing over a range of temperatures. In your case, I believe that you guys have, I think you can just leave this. You can figure out a temperature you think it'll run at. I think you have to estimate that. So you can click run analysis. So essentially you'll change your pressure and temperature, but anyways, you will get your KVL values at 1.01 bar or 1 ATM. And you can see here's a graph. If you don't want to see it in the graph tab, instead of the plot, go back to this tab, you click results, and now you can see all the values at different temperatures and pressures. And this is what you can report, and you can cite Aspen when you do the K value and find the alpha value, relative volatilities. So right here it says reference the source of any data you obtain. So for FUG calculations, you should find your K values. It would be best if you find it from Aspen using what we just did. Also with the properties right here, you can just screenshot this. That's the best method. You can just screenshot the part you care about. Okay, so we're gonna move on to step 2, which is now simulation. Okay, so for simulation, we're gonna use a column. This is all we really care about in this problem. So the only two types of columns you really use in chemical engineering here are distwu and radfrac. So basically, distwu is a shortcut distillation column. Radfrac is a rigorous distillation column. You should be using radfrac for this column. As you can see right here, so we have a radfrac. So you can see here, you can zoom in or out. I have a mouse, so it's nice to scroll in and out and you can zoom in. So once you have that, you want to have material feed going in, right? You want to have, there's a liquid distillate or a vapor distillate. We will have a liquid distillate. Both of our products are liquid. And our bottoms is going to be also liquid. And so another thing you can do is, I'm going to just click the cursor. You can click here. And if you want, you can just click align and that will straighten things out for you. So we aligned them, and you can always click reroute stream if you need to change the source or the destination. So I'm just going to rename these for Sandy, feed, distillate, and then this is bottom, so I'm just going to write bot. And this can be our column. That's the name of our block. So you'll have block and streams in Aspen. Those are two things you'll have. So I'm just going to name it column. So we can see here, there's the bot distillate feed and block and column. You can see the red means required and complete input. So once we have that, we're gonna put our temperature. Let's say our temperature is at the column. Let's say the column is operating at like 100 degrees Celsius. I'm gonna just make up parameters, one bar or something like that. You can change units right here. Let's say we have components. So you can do it in flow or fraction. I'm gonna just use mole fractions and just say we have a total flow rate. Let's say we have 0.2, 0.3, 0.4. It's gonna add it up for me here. Actually, let's say 0.3, 0.1. Let's say we have 0.1 of this. So then let's say we have 100 kilmoles per hour. So now it's all specified. Great. We're gonna go to the column. We're gonna need to specify this guy too. And so you're gonna leave it as kettle, reboiler, thermofit siphon, or kettle. We're gonna use it as kettle. It's a vapor liquid, so leave it as that. Conversion is standard. These other ones are for like azeotropic or cryogenic. We're not going to use that ever, so just use standard. So the goal here is you need to put the total number of stages. Let's pretend I'm just going to approximate, let's say we have 30 stages. So it'll give you the different types of feed that you have. So you should put your components based on this composition when we put it into the feed. I didn't base it off this, but you guys need to use that. And you will use, I guess, 8.15 ATM initially. You can change the pressure as well, I think. So this is ATM, atmospheres. Okay, so then we put the column. Let's say we have 30 stages. Our condenser is going to be total, so put total condenser. And then you need to put a distillate rate. So you need to have two specifications of all of these. So we can put a distillate rate, bottoms rate, reflux rate, boil up ratio, distillate to feed ratio. That means that's the V over F, or you can have L over F, condenser duty or reboiler duty. So you can specify something. Reflux ratio is a common one, so you should have that probably as one of your specifications. Distillate rate is probably the other one that you can specify. So that's your rate D. So let's say we have like 20 for distillate rate, let's say 2 for the reflux ratio. Streams. Okay, so you have to put your feed stream condition right here. So you can specify this. You can see right here. Let's say it's at the 10th stage. So it's going 10th stage. This is above stage, so it's coming in from the top of that stage. So it's 1 to 30, and we're feeding it at 10. Remember, you count from the top to the bottom. Okay, so yep, it says top to bottom. Pressure, you can just put the same thing, 8.15 ATM. Okay, so everything's specified now. Great. You can go next. Okay, the next thing we need to do now. Required input is complete. We can run a simulation. So great. You need to run the simulation first on just base estimates or parameters. You can see it did not converge, unfortunately. And then let's run this. Reset. You want to reset the simulation, then you run. Resetting isn't good on practice unless you do tier streams and recycling, which you'll do later. It's a good practice to do that. It says results are available with errors. Sorry, I lost my Aspen file, so just make sure you always save it. So this is resuming. Remember, we put in our feed. We specified a component mole fraction. It says mole flow. Just say mole fraction. So this is mole fraction. You can see the total flow rate, and then the pressure was 8.15, and then I just said, let's say we'll have a temperature of 100 degrees Celsius. Probably should be lower than that, but then we'll set up the column. So I'm going to go back to that, sorry. So then it should be equilibrium based. Then you put in your number of stages. So let's pretend we have 15 stages. We put total condenser. It shouldn't be already specified, but we'll say that. Let's say our distillate rate, let's say it's like 50. Our reflux ratio is about 2 or so. Streams. Okay, so then we want on stage, actually, not above stage. So you want to click on stage. That means it's feeding at that stage, not above that stage. We're going to have, let's say, because we have 15 stages, let's pretend we're starting at like stage 8, because that sounds around right. Number 1 should be your distillate first stage, so it's counting top to down. 15 should be your bottom stage, and you'll have both of them in liquid phase. Remember, they're not vapor, they're liquid. once you have that, you can specify your pressure. So once again, it should just be 8.15. You don't have to touch anything else. This is a top stage. We'll just pretend everything is happening at 8.15 ATM. So it's like kind of isobaric in a way. Although in reality, you probably have a pressure drop. So we'll just do that. And then once we have that, we can click reset. And then we want to click run. So the blue check marks means it's good and everything has been specified. So hopefully it will work this time. Once this works, I'm gonna go over how to do the specification. Yeah, how do we do the sensitivity analysis? So okay, it worked. Great. Check status. It says there is no errors and you can see everything looks great. Once we have that, you don't want to close the main flow sheet, so don't do that. Okay, so main flow sheet is where we can see our rad frac column. You can see the feed, the column, distillate, and bottoms. And so once we have that, you go to home. And home, these are the two most important things, model summary and stream summary. So we want to click stream summary. Stream summary is very important. You can see bottoms, I can change this. Let's say feed, distillate, bottoms. That just makes most sense to me. So you can see here, we have a cost flow. You can do economics later. It's not for this class. We have it in vapor phase, feed. We have distillates in liquid phase and bottoms in liquid phase. Don't know why it says my feed is in vapor phase. That seems a little odd. I would just encourage you to double check right here what it says your feed originally is. I believe our feed should be a liquid. So let's change that. Let's change this, let's change it to like 50. I think it's saying it's a vapor because my temperature was too high. So just watch out because you don't want the temperature or pressure to be too off that you're in the wrong phase on the phase diagram, because remember temperature and pressure impacts your phase or state of matter or your phase on a phase diagram. So we're gonna quick run again because that didn't look right. So it's still calculating. You should get U drive. Hopefully we can figure that out. I don't have time to contact IT right now, or I would have done that. It's a little frustrating, mainly because of a lot of wait time. We're gonna click stream summary. Once again, feed. Okay, they're all in. So that was a good lesson because we double checked and we're like, why is this in vapor? So you do have some threshold in what temperatures you can use. You cannot use anything that will give you vapor or solid. So we're on liquid. That looks great. Temperature is 50. It seems like the temperature is lower in the distillate. So it's lower in the condenser than the bottoms. The bottoms reboiler has like about maybe 97 degrees. That looks right because reboiler is going to be hotter than the condenser. Pressure, they're all the same. And it's in bars. You can change this. Remember, you can change the unit. So it's all 8.15 ATM. That's great. Okay, so we don't really care about that part too much. We don't care about this part either. Enthalpies and stuff, we don't really care. Molecular weight, who cares about that? So mole flows. This is sort of helpful because you can see it's 100 and then we split it 50-50. So 50% of it is in the distillates and 50% is in the bottoms. You can see the specific mole flow rates, but what's more helpful is mole fractions because then you can see what's going on with the separation. So you can see we started out with these components, and you see, for instance, N-pentane is almost 0 in the distillates, and most of it has gone into the bottoms, which is great because you can see most of this component has come here. But then you can see something like propane, which is the lightest component, is barely in the bottoms. So you can make up assumptions that it's like 0 in the bottoms. You can use heuristics to do that when you do your first calculations for FUG method by hand. So you'll do that, and then you're going to do the rigorous calculation by Aspen. And then, okay, so that looks great. You can take screenshots of this. Unfortunately, you might have to take multiple screenshots and like put them together. Remember the units here should be like kilowatts or something like that. So make sure to change these units. They're all in calories. And then once you have that, you're going to need to look at the block. So when you click block, the other way is you can click results off streams and it will give you the results of that particular stream. So that's another way you can navigate, or you can click stream summary, which I recommend. We're going to click specific column like results. So under column, which is our block we want, we click results. That's going to give us the block summary for that column. And so you can see right here, we have the condenser. It gives you the heat duty of my condenser. We want it in kilowatts. We want the heat duty in kilowatts here too. So I can see it's about negative 753. That means it's exothermic. We're removing heat, 753 kilojoules per second from the condenser. We're putting in 877 kilowatts into the reboiler. That looks right. That looks reasonable, basically. So then once you have all of these, you get the distillate rate right here, reflux rate. So RRD, you can get the boil up rate boil up ratio V sub B, and you can get B, the boil up rate. Bottoms rate is B, actually. You can get all of these parameters. Once you have these parameters, you're going to report those. Okay, we're going to talk about sensitivity analysis. So you can have optimizations. So you have, I forgot what EO stands for, but I think this is optimization. You have optimization here, you have sensitivity. We're going to be using sensitivity. There's no reason to optimize because we don't need one value. We want to see the whole progression. As you vary one parameter, what is the impact on another parameter? We want to see that whole curve because we can analyze which is the most optimum ourselves. We don't want just one point given. So we're going to be using this. You click new, it says S2, okay. So sensitivity, it might say S1, I don't know why it says S2 here. So we're going to click S2, that's great. So you click model analysis tools, sensitivity. Now we created a new parameter called S2, okay. So once you have S2, we have a vary tab, define tab, and tabulate tab. So we're going to vary what variable? We're going to define certain variables, and then it'll tabulate certain variables we want. So first, we're going to click new. It creates one. That's great. Variable one. You can just say one. So then once you're here, you want to choose a block variable or a stream variable. Those are the mainly two things you will see. You can vary like the inlet stream pressure. Let's say we want to vary the operating pressure. So we're going to click right here, block. We're going to click column. We're going to click the variable we want, which is pressure. You can just alternatively click this so it's easier. Pressure, search, stage pressure, set. Yes, we got stage pressure, so that's operating pressure. Great. We want it in ATM, let's say, instead of bars. We're going to start, so we need to manipulate this. So where do we want to look at pressure from? So we could say, let's say from 0.1 ATM to maybe we want to see what its impact is if we go up to, like, let's say 10 ATM. The number of points, you can either give the total number of points you want or increment it. Let's increment it by like 0.5. Actually, maybe we'll do this from 1 to 10. So you can see right here, what's going to be the impact of doing this? So then we don't want too many points. So don't make it so it's like 500 points. That's going to take forever. Let's see what else I needed. Next, ID 1 should be specified. I think you can just put number. Yeah, that works. Okay, so then variable, you're going to click new. You want to type a variable name. So you want to type something that makes sense. So I guess for mine, I want to see what the operating pressure's impact is on an outlet variable. We want to see what its impact is on, I guess, like, let's say whatever our light key is. So you got to find the light key and the heavy key. So we want the separation, I believe you want the separation right here. You can see it should probably be between N-butane and I-butane. You can see because these are the largest components. So the split should be between N-butane and I-pentane. Say, let's look at the N-butane. Let's look at N-butane like, okay, I'm just going to call it N-butane. We want to see the mole. You can either do mole fraction or mole flow rate. I want to see an impact on mole fraction. So we'll call this N-butane. So this is a stream. That's a stream parameter. So we'll click stream. Then you want to click type. What do we want to see? Okay, so we want to see its impact on the mole fraction. So let's say mole fractions of the distillate. I want to see how much is in the distillate. We want a mixed substream. We want the component, which is N-butane. So we click that. So great, we got everything defined. You can do the same thing with a block. You can do this with like heat duty. So you'll click block, column, and figure out the heat duty of the reboiler or the condenser. So then once we have that, we are going to tabulate this. So we want to put variable 1 N-butane, I think. So 1, and then you want to see N-butane. So you can effectively do this for similar to Excel. You can plot like one X variable and see the impact on multiple parameters. Okay. It had some warnings. sensitivity blocks, they're annoying. They always have some problems. This went pretty quickly, I guess. So when you click sensitivity, you can click results, and you can see the results right here. There's some warnings here. I guess it's because you can't really raise the pressure above 8.25 or something. But once you have that, you can click a results curve, or you can click custom. You can plot any variables you want, just like Excel. So we want to click results curve. So we want to vary this. We want to have N-butane plotted when you vary X. So you see this beautiful sensitivity analysis curve. Right here, it seems like our pressure, our N-butane mole fraction is highest when our pressure is around 6.59. And you can see it's about 0.418. So that's the useful thing about sensitivity results. And another neat thing is I can plot multiple things. So what if I wanted to see not just N-butane in the distillate? What if I wanted to see something else? So I'm going to define a new variable because I want a new. So this is similar to your X variable. So if I'm going to annotate, so this would be like your X variable. This would be like your Y variable. And the tabulate is asking you what you want plotted. Sorry, this video is becoming very long. Okay, so once you have that, we can create a new variable. So N-butane, let's say we wanted isopentane, so the heavy key, I-pentane. So I'm going to type I-pentane. You can just name it whatever you want. We're going to now define what this variable is, I-pentane. So let's say stream, let's say type. So we wanted a mole fraction. We're going to click that. We're going to click of the bottoms because I want to see how much heavy key is in the bottom. Click N-pentane, and then great, boom. And then we just need to type N-pentane right here, and just click 2. Call it number 2. And then once you have that, you're gonna click reset. Let's say reset. And let's run. Let's see what the impact of operating pressure is. And then you can always vary the other ones like reflux ratio and feed location and number of feed stages here. And if you need help, always feel free to ask during office hours. So we'll wait, and I guess it ran. So this is perfect. Okay, it has some warnings, but that was the same thing I talked about before. So let's say I click the results, and then I wanted to add and edit the legend right here. Say I'm gonna close out of that. I want to have the results again, and then I want to create custom. You vary this. I want both of the curves to show. You can see N-pentane. It doesn't show very well on the same plot. I guess this is questionable that N-pentane looks very low. You might need to change your axes. There are ways to manipulate this. Y-axis map. You can click single axis if you want. That might fix things, and you can see how it looks on the same axis. Y-axis map, individual y-axis. I'm not sure why they all look around 0. You can always double check what's going on in the results. I guess they're all 0 for some reason here. So I would just double check that. It looks very questionable. I'm going to give you one other example. That's that. You can always create a new sensitivity analysis. We can click hide. And you can click, I'll just reveal it. Reveal, say we reveal that. So I can make it inactive so it doesn't run. You don't want to run all of them at once. So let's see what this one was. I guess there was nothing on S1. But okay, so we can see, do another variable. We can see a type. Let's say we want to vary something such as, you can vary the reflux ratio. Let's do that. So column, let's vary reflux ratio. That's a long list, so I would just type right here, reflux ratio. Specify more reflux ratio, select. Great. Okay, so once you have that, let's say we want to vary it from like 1 to like 5. increment it in like 0.1. So once we have that, that's great. Define a variable. Let's say new. We're just gonna call this. We want to see reboiler heat duty. So I'm just gonna call it reboiler block. This time you'll click block, and then you're gonna click type block variable block column variable. We want to get the reboiler heat duty. So you're gonna Google that. Calculate reboiler duty. Great. Select. We want the units to be in kilowatts. So great. Tabulate. Column 1. Let's say a reboiler. You need to match the exact same name that you gave right here. And then we can click reset. Okay. Also, I'm gonna add one more variable while we're at it. So let's say condenser. We want to see the condenser heat duty as well. So block variable, block column. We're gonna Google condenser heat duty. So right here you can see condenser pressure drop. Let's look for heat duty. Condenser. Okay, found the condenser duty. Okay, great. So it's called condensed duty. And then once again, we're gonna have in kilowatts. Tabulate column 2 condenser. Okay, so it's called condense here, so it shouldn't be called condenser, it should be called condensed. Okay, so then once we have that, we're gonna reset simulation. Okay, purge it, run. Okay, so results are now available, as you can see right here. So then we can click results curve. We want to vary that. We want to vary the reflux ratio. We want the reboiler and condenser duties, so click OK. Great. This looks great. This looks very realistic. So basically it's telling you the reboiler heat duty is increasing as you increase the reflux ratio. And then your condenser heat duty is decreasing as you increase the reflux ratio. So I guess you can see like trends like these, for instance. Remember the scales are a little different. This would look different if you had it in one single axis. So you can see here, it like increases that way, it decreases this way. So that's a similar trend that you can analyze and talk about. I think that is one of the trends to talk about. Okay, so I don't want this video to be much longer than this. I hope that helped. And if you guys have any questions, don't hesitate to ask. Also with simulation and sensitivity analysis, you must have a U drive. It's gonna take forever without a U drive. So just also note you should save. So make sure you click save. It's not responding. It'll be like that a little bit and then it'll save. But also just consistently make sure you save your file, because if you don't, you might lose everything that you've been working on for an hour, which is what happened to me earlier, because the first half of this recording I was using a different file than the one I have right now because I couldn't find the one I had initially. Yeah, so that's it. Okay, don't hesitate to ask if you have any questions. Yep, bye guys.